Hey everyone, Mr. Sharkey here. We're going to go through some notes together that are in our Unit 2 notes packet. So that's the blue packet for Unit 2. If you remember back to the beginning of the unit, we've already gone through this smelly particles demonstration. We've also already done this liquid diffusion demonstration. So we're going to spend some time today taking some of the rest of these notes. As we work through things, anything that's in red, I need you guys to copy down. And then any of the particle diagrams you should also be drawing as we kind of go through these notes. So we've talked about most of this material, we just haven't written all of it down. And then towards the end of these notes, we're going to finish up some of the gas laws, which we started talking about in class during the last in-person day. So if we look, we're going to start off by talking about the three main states or phases of matter. So we have solids, liquids, and gases. We've started talking about all three of these, but in this unit, we've mainly been focused on gases. One of the first things we did in this unit, we drew particle diagrams of solids, liquids, and gases. If we look at the solid, when we draw a solid particle diagram, we want to make sure those particles are very compact. So they're pressed together. That means that our solids are usually pretty dense. Also, solids will hold their own shape. So if we look here, my solid is in a square. It's not taking up the container. It's able to hold its own shape and kind of be on its own. That means that most of our solids are also pretty organized because their structure doesn't really change. And then when we talk about the movement of particles in a solid typically just vibrate. So very small vibrations back and forth. If you follow my cursor, a solid particle would probably look something like this if it was moving. If we look over at our liquid, the particles are a little bit more spread out because the particles are going to be moving more. They take the shape of the container, so they're not going to hold their own shape. If we pour a liquid into a cup, the liquid is going to take the shape of that cup. Our particles are a little bit less organized because they're moving around now. Particles in a liquid might kind of oscillate back and forth a little bit like my mouse is doing right now, but they're going to be less organized and they're going to be a little bit more spread out. Finally, the main thing we've been focusing on in this unit, are gases. When we look at a gas, our gas particles are moving fast, so we start using our little lines, which we've called whooshes, to show that the gas particles are moving. Our gases are going to fill their container, so rather than just taking the shape or spreading out along the bottom like our liquid does, a gas is going to fill the entire container. They'll move around randomly because they have so many collisions with the other gas particles and with the walls and anything else that's in the container. And they're going to be the most spread out because our gas particles are moving so quickly, they are not clumped together like our liquids or our solids. So take a minute. If you need to pause the video, you can do so to draw these particle diagrams and then also take these notes that we have down below. When we look at gases, a couple things that I want us to, or things that we've discussed, but we haven't necessarily written down. So when we look at a gas, we can compress a gas. Gases can be compressed or made smaller. So if I have something like a balloon, I can squeeze that balloon and I can push that gas closer together. On the opposite end of things, gases can also expand. So if I have a balloon and I let go of some of that pressure, the gas will expand, making the balloon a little bit larger. So when we talk about the volume of gases, we say that they are variable. That means that the volume of the gas can change. We can increase their volume, we can decrease their volume, depending on the container that we put them in. The last thing that we're going to talk about in this short little video is the kinetic theory of gases. This is 4 rules that we have about gases that we've talked about, but we haven't necessarily defined. So whenever we're talking about gases, we are always going to keep these four rules in line. Gas molecules are always going to move in a straight line. If you think about how we've been drawing them, we've always given them a straight tail to show that our particles are moving in a straight line. Average kinetic energy is going to increase as the temperature increases. So this part is, it sounds really complicated, but all we're saying there is that as the temperature increases, our particles are going to move faster. Kinetic energy is just the energy of motion. So if something has more kinetic energy, that means it's moving faster. What we're trying to say is that as the temperature increases, so does the speed of the particles, which means the kinetic energy is increasing. So we've shown that because if we have a particle moving faster, we give it more tails or more whooshes. The next point is that collisions between gas molecules are elastic, meaning that there's no increase or decrease of kinetic energy. What that's saying is that if I have two gas particles that are coming together and colliding, when they bounce off of each other, normally we would expect them to slow down a little bit. But when we're talking about gases, we're going to assume that when they collide, they're going to bounce off at the exact same speed. So they're not going to go any faster or any slower after they collide. And then the last thing that we assume about gases is that there's no attraction between particles or between molecules. So when my gas particles are coming closer together, when they hit each other, they're going to bounce off. They're not going to get attracted to each other in any way. And these four rules we just think about because it helps make gases easier to understand. If we ignore these four rules, then we make things a lot more complicated. So to make our lives easier, we just keep these four things in mind. You don't have to memorize these four rules. It's just something I want you to know. I'm going to pause this video here, but we'll continue going through the notes in another one.